So from today on, we'll start learn Unit 3, which is about exponential and logarithmic functions. So today we'll have a look at the exponential functions first. Today's learning goals. After this lesson, you should be able to determine if a function is an exponential function or can be obtained by transforming an exponential function. Sketch the graphs of exponential functions and understand and interpret the main properties of exponential functions. So first of all, let's have a look at the definition and main properties of exponential function. The exponential function has a form y equals b raised to the x power. B is base and b is greater than 0 and b cannot be 1. Okay, so note here there is a constraint for the base b. And exponential functions has a domain x belongs to the real number set. And the range of the exponential function is y belongs to any number that is above 0. The exponential function has a y-intercept 0, 1. And it has horizontal asymptote at y equals 0. There are two types of graphs for exponential functions depending on the value of b. If the base value of b is greater than 1, this function will look like a graph on the left side, which is increasing on its domain and crosses 0, 1. And if b is greater than 0 but less than 1, this function will be decreasing on its domain and also crossing 0, 1. Okay, so remember that there are two patterns of the graphs for exponential function depending on the value of the base number b. Right? So here are some examples of the exponential functions. First of all, if b is greater than 1, for example, b is 2 and e and 5. These functions is increasing in its domain. The other set of exponential functions, all of them has a base number b greater than 0 but less than 1. For example, here the graphs show the base number are 1 over 2, 1 over e, and 1 over 5 respectively. These functions has a decreasing interval in its domain. Okay. All right. There is another important property which is called the proportional finite difference. Let's use this function as example. The function is y equals 3 to the x. First, we can sample some points on this function. When x is 0, 1, 2, 3, 4, 5, y is 1, 3, 9, 27, 81, 2, 4, 3, respectively, right? And then we can calculate its first difference. For example, when x is 1, first difference is 2. When x is 2, first difference between x being 2 and 1 is 6, right? Because 2 is simply 3 minus 1, 6 is 9 minus 3, and 18 is 27 minus 9, 54 is 81 minus 27, and 162 is 243 minus 81, right? Okay. The first difference are proportional to successive y values because their ratios are equal. What does this mean? This means if you use this number divided by this number, this value should equal to this number divided by this number. This is called the proportional finite difference. For example, if you calculate 27 over 9, this value should equal 18 over 6, right? And also 81 over 27 is also equal to 54 over 18, etc., right? Okay, so next time when you see a proportional finite difference, maybe you can consider using the exponential function to model the data, right? Okay, so let's have a look at a practice. Write an equation to fit the data in the table of values here. So as I said, you can calculate its first difference, right? First difference we can calculate from here. 4 minus 1 is 3. 16 minus 4 is 12. And 64 minus 16 is 48, right? So note here the 16 over 4 is 4, right? Which is equal to 12 over 3, right? And also 64 over 16, this is also 4, which equals 48 over 12, right? So that means the difference are proportional. So we can consider model this data using a exponential function, right? Y equals b to the x. And we can put a pair of xy to determine the value of b, right? For example, when x is 1, y is 4. That means 4 equals 1, b to the power of 1. So that means b is 4, right? So these data can be modeled using the function y equals b to the x. B is 4. So y is 4 to the x power, right? And next, let's check if this function works for all of these data. Well, x is 0, apparently y is 1, right? And when x is 1, y is 4. And when x is 2, y is 16, right? When x is 3, y equals 4 to the power of 3, which is 64, right? So that means this function works for this set of data. Right? You can also check the solution of this problem in this lecture slides after the class. Okay. All right. Next, let's have a look at the transformations of exponential functions. So just like the transformations we have learned in Unit 1, we can apply the same principle to translate exponential functions. For example, the original function may look like this: fx equals b to the x, right? And the transform function has 4 parameters: a, k, d, and c. And the new function may look like this: a times b raised to the k times difference of x and d, and then plus c, right? Remember that a corresponds to a vertical stretch or compression. And if a is below 0, reflection in the x-axis. K corresponds to a horizontal stretch or compression. And if k is smaller than 0, reflection in the y-axis. C corresponds to a vertical translation up or down, right? And D corresponds to a horizontal translation to the left or right. And remember that we do the translation represented by A and K first, and then followed by C or D, right? Okay, so now let's do a practice here. I'll give you 5 minutes to think about this question, and then after that, we'll have a look at them. We'll have a look at it together, okay? All right, you can start. All right, so have you finished? So note here, the first parameter is -3, right? This corresponds to a vertical stretch by a factor of 3 and then reflect in the x-axis, right? Next, this is the parameter k, which is 4. That corresponds to horizontally compressed by a factor of 1/4, right? Next, we have the parameter d, which is 1. That means a horizontal translation 1 unit to the right. And last is the parameter c, which is positive 2. That means a vertical translation by 2 units up, right? Okay, so in a summary, you can check the solution here. And also, I have drawn a translated curve here, which is y equals -3 times 2 raised to 4 times x minus 1 plus 2 in comparison of the original curve here, which is y equals 2 to the x, right? You can check the relationship between these two curves here. Okay, so next let's do another practice here. So this time you're given a graph of a function and then write an equation for this exponential function. Okay, I'll give you 3 minutes to think about this question. Okay, any ideas? The form of the function should be look like this, right? Y equals e raised to the x. And in order to find the value of b, we can put any value in this curve in, right? For example, we put this value in. This value is 1, 3, right? So 1x is 3, y is 1x 1, y is 3. So that means 3 equals b raised to 1. So b is 3, right? Therefore, the function is y equals 3 raised to the x. Right? You can also check the solution using other points along the curve, right? Okay, now let's have a look at another practice. Okay, I'll give you 5 minutes to think about this question. All right, so let's have a look at the solutions. How many people have the virus at each time? So this basically asks when t is 0, 1, 2, 3, what is the corresponding value of n, right? So first of all, when t is 0, we can just put t be 0 in this equation and find n is actually 10 by 1, right? Which is 10. And when t is 1, n is 10 by 2, which is 20. And when t is 2, n is 10 by 4, which is 40. And when t is 3, n is 10 by 8, which is 80, right? Okay, so these are the introduction to exponential functions. So let's make a summary of what we have learned today. So first of all, we have learned the definition of exponential function and the main properties of exponential functions. Remember that there are two patterns of the exponential functions, depending on the value of the base number b, right? And you should also be able to analyze the transformations of exponential functions following the principles we have learned in Unit 1, right? Okay, you should also be able to sketch graphs of exponential functions and understand and interpret the main properties of the exponential functions, okay? All right, so these are what we have learned for today, and the rest of the time is for you to complete today's homework, okay?